Just in my last session, weren't you, Andre? Good morning again.
Morning, sir.
Right, okay, everyone. So, welcome back to most of you. I think, I'm not sure if it was all of you, or I definitely recognise a lot of those names come up from the register before, but this is a session for further maths. So that is qualification in addition to the maths A-level. So getting yourself to A-levels basically, and you know, going that little bit deeper into maths, and you know, do some more difficult stuff really. So for I think most of you, if not all of you, let me just have a quick check again. Okay, yeah, I think all you guys were in the one I've just done. So most of these expectations are, you know, exactly the same. And obviously just re-emphasizing the challenging aspect. Honestly, those of you successful in going on to further maths, you won't even believe how far you're going to get. It's really challenging, but obviously, again, super rewarding in terms of, you know, what you can do afterwards. The same as maths, we've got those three elements. We've got our core element, and we run further maths with statistics and mechanics. You know, we've got basically the same kind of thing, but just more difficult. So it does mean you have to you get more books, for example. So there's the further core books, which are the green ones, again, get you one. And then there's an orange book, which is, I don't know if I'm remember that right. That's the green one there. I've got a green one in front of me. I don't know if you can see these on the back, but you basically need FS1 and FM1, which are the red and orange, one for statistics, one for mechanics. And then for year two, you only actually need one extra book, because you need the green book that's year two rather than year one. So it looks very similar to this, but it's got book two on it, or year two, book two. But the second part of the A-level for the applied are in the red and orange book as well. So, you know, but obviously there's time to sort all that out and get all the information regarding which books you use it as well anyway. Obviously definitely get your year one stuff ready, and if you're doing further maths, the definite, which I hope you are, obviously, as I mentioned in the last one, you probably want to get your year two book for the normal A-level, so the blue one, a bit earlier, and probably applied anyway. I mean, if you're picking further maths and doing further maths, you're definitely going to get and do year two normal maths. So get those early. The earlier the better, because we do some of that work before we do some of the further maths work, if that makes sense. So some of the year two normal maths before some of the year one further maths. It kind of helps out a little bit. Okay. For further maths, we do the AS examination. So that's just for the further maths element. So you'll do the exams at the end of year 12, you'll get an AS level for that. And then obviously you need to do well if you want to carry on into year 13, but it's really to offer you that flexibility. So some of you will be choosing 3 subjects, you'll be doing maths, further maths and something else. And in that case, you'll just continue in with those 3 subjects throughout. You still do the AS level, but you know, obviously you're going to continue because you're only doing the 3 subjects. Some of you might be choosing 4 subjects, so maths, further maths, and 2 others. And then a little bit later on, you might want to make the decision about you know, what uni courses you want to do, what you're looking at next year, so which one's more important. Some courses would rather you didn't do further maths. They're just more designed towards other things. So that would be perfect opportunity, get an AS in further maths and move on and do your normal maths and your other subjects. But some of you would obviously, hopefully as well, continue with further maths and perhaps drop one of those, you know, those other 2 subjects that you know you've chosen something else. The good news is same calculator. Again, you can get the more expensive one if you want, but that one will do everything you need to do. You'll be absolutely fine going to the exam with that. There's another summer task. It is a second subject, so you will feel like you're doing maths all the time, especially if you're only doing 3 subjects, but that's because 2 of them are maths, so 2/3 of your time will be maths, 1/3 will be whatever the other one is. And everything else is the same. Okay. Again, I'm not going to go through this again. You're all in the last session. Detailed, organized folder, marking it, all that stuff. Make sure we got that. So further maths folder, same. Okay, so we're going to look at complex numbers. This is one of the first bits really in third maths. It's probably something that you might have heard of before. You know, it's kind of one of those things that teachers often mention, and just for a little bit of interest, particularly if you're, you know, good students and confident. But we're going to go through a few bits from it in a little more detail. So, imaginary and complex numbers. Complex numbers really basically exist because at some point we want to take a square root of a negative. It's kind of the crux of it, and it allows us to solve problems that before we used imaginary or complex numbers we weren't able to solve. Okay, and you know, so it's kind of invented in a way to be able to allow us to solve the problems, but it allows us to solve problems really good, particularly in engineering, a lot of electrical engineering and things like that. Anyway, the vast majority of what we do at A level is sort of playing around algebraically and doing things like that. Okay, so you're not getting to like super, you know, complex problems involving in different situations, and that it's going to be more sort of abstract and algebraic. So We can see, based from a quadratic equation, and you probably come across this if you've tried to solve some quadratic equations before, that sometimes, your calculator just says maths error. And basically, because that bit under the square root there, that b squared minus 4ac, is less than 0. It's a negative. Okay, and if that happens, there are no real solutions. Okay, so your new calculator wouldn't tell you that. It would give you the solutions, the imaginary and complex solutions, if they exist. So we basically extend our number system. We expand it to include the square root of negative numbers, specifically the square root of -1. We can write all other negative square roots from square root of -1. So we know that we can't get any number that when we square it, we get -1. So that's an imaginary number, and we represent it by the letter I. Very imaginative there. If we have real parts of numbers and imaginary numbers, that's when it's called the complex numbers, because we've got the real and imaginary part. Okay, so that example there, we've got the real part 3, and then the imaginary part 2i. So that's a complex number, the 2i being the imaginary, real part. So an imaginary number is always going to be written in that form, sort of bi. So 2i, 5i, 7i, whatever. Okay, and a complex number is going to be written as a plus bi. You've seen the example there: 3 plus 2i, 5 minus 6i, or whatever it comes out as. So we're going to write each of the following ones here in terms of I. So this basically, I mean, you're not going to do this each time, but or feel free to jump in if you think you know what it is already. There's only a few of us, so you can give it a shout out and go for it. Anyone just a stab at Faye? Not sure? All right. So square root of 36, if you use a bit of surd work, we could write as root 36, root -1. Yeah, that makes sense. You can do surd. You're trying to choose surd maths. So root 36 is 6, and as we've just discussed, the square root of -1 we call I. So we got that there as being 6i. And so that's kind of, what we're looking for really. If we're solving a quadratic and that bit underneath the square root turns out to be -36, we can make it 6i and get a solution. So the square root of the -28 over here, we're going to do the same thing. So let's make it square root of 28, square root of -1. So the square root of 28, well, 28 is not a square number, is it? So we can't just, it's not as simple as the one before, but we can simplify a little bit, can't we? Root 28 is root 4 times root 7. I hope you remember simplifying surds. So we're kind of breaking that down even further. So we have 2 root 7, and the square root of -1 is I. Okay, one thing to note with this, make sure that square root there stops. Some people like to put a little down bit on the end to make sure it stops after the 7 and doesn't carry on over the I. And in fact, you'll see some people will write it like this to avoid that. Obviously, those things are equivalent because all three things are just multiplying each other together there. Okay, but it doesn't particularly matter. But you'll see some textbooks like to go this way. That's just because they don't want to. Yeah, they don't want to confuse it and make the I look like it's underneath the square root. And some will do it this way and just expect to realise it. But obviously, the root symbol needs to stop. Okay. Some might even put a bracket around it like this. but you know, all three things are the same. Okay, so we can do other things, other sort of basic things with numbers, complex numbers. We can do other simple things. We can add and subtract them, and we can multiply. We can do, you know, multiply brackets, things like that. So we can do all these things in kind of the usual way. So we're going to have a little look at these here. So first one is basically like collecting like terms. I've got these two complex numbers, but here's a real part, here's a real part. So 2 plus 7 is 9. Here's an imaginary part, here's an imaginary part. That's all positive, isn't it? So 5i plus 3i, it's just going to be 8i. Right, so we do all these standard normal things that we're used to doing. 2, and then you can see we've got minus 5 there. So 2 minus 5 is minus 3. We've got the minus 5i, and this is going to be plus 11i, isn't it? Because of the minus here in the middle. So we've got that minus there. So we get a plus 11. So minus 5 plus 11 plus 6i. Okay, multiplying at brackets. How we normally multiply brackets. There's nothing special happening here. All nice. Dividing. It's what? All the same. It's going to be 5 plus 3i. Okay. Hopefully you're thinking, all right, not too bad. This is quite easy. All right, so it's a nice introduction. Things do get more complicated, but let's just have a quick go then. Let's just pick out a couple. In fact, just pick out for yourselves. Pick out one to do from question 1, one to do from question 2, one to do from question 3. Pop your answers in the chat. Obviously, just label them like 1B, 1H, whichever one you're doing. And let's have a look at you guys doing a few answers. Or if you prefer, just tell me. All right, anyone got anything? Stick it in the chat. Shout it out when you're ready. Any answers? Or if you're not sure about one, you want me to do one? Right, here we go. Save answers. All right, looking good with those answers. You got anything to add? Any answers from question 2 or 3 on there? Anyone done any of those? Again, not expecting them all done. It's just a little taste today, so just 1 or 2 questions. Let's have a look at that. 2J, what are we going? 2, 2, 2. Familiar. H. Oh, okay, right, yeah, okay. 2 root 2 plus 2i, yes, that makes more sense to me. 2 root 2 plus 2i, perfect. All right. Okay, right. We're going to move this on. I think, that's all kind of straightforward stuff. Hopefully you've managed to do a couple of those. And, if you've got any questions, correspond at the end, or you can just pop anything in the chat. We'll sort them out. So we're going to move it on now. So we're going to be asked to solve some equations. And basically equations that we probably wouldn't have solved before. We would have just said, well, there is no solution. And you're going to see the letter Z used quite a bit. So in sort of this context where we are now, Z is kind of giving it away that it's a complex number. We would kind of, if we're using some complex numbers, we would have like Z equals 2 plus 3i. And then when we're talking about Z, we're really referring to that complex number or whatever it is. Or it could just be imaginary. So if we were going to solve this equation, well, what we usually do, we'd usually go, well, all right, Z squared is minus 9. And then we'd want to square root it, right? So we'd go Z equals square root of minus 9. And we'd usually stop and say, well, you can't do that. There isn't an answer. But now we can give an answer. All right, so we're going to do what we've just been doing, splitting that up, root 9, root minus 1. So 3i. Okay. So in this case, it's just imaginary, but we've got a solution of 3i. Now, it's not technically true. That's not the whole solution, because what did we do? We square rooted something. Now, what happens when we square root something? Well, we get that plus and minus, don't we? We get the 2 solutions. Okay, because what we've done, we've made it square root of 9, square root of minus 1. And so square root of minus 1, that is indeed I. But square root of 9, it could be 3, it could be minus 3. So we've got that plus or minus 3. So our final solution is going to be plus or minus 3i. And so you're going to find that when we get complex numbers and solutions, they come in pairs. Okay, so we're going to solve another one, and then we'll have a few of those as well again in a minute. So if we're looking at this one, I've got z squared plus 6z plus 25 equals 0. So again, I'm saying, right, initially, I've got a quadratic equation. I'm going to solve that. Can I factorize it? 5 and 5. No, it doesn't. No, can't really factorize that. All right, what are we going to do then? We use the quadratic formula. We're going to complete the square. That's an argument to be had, isn't it? We know they both give us the solution. Let's use the formula. Okay, you can complete the square if you want to do it while I'm doing the formula. But yeah, let's do the formula. So minus b plus or minus the square root of b squared 36 minus 4 times 1 times 25. So that's minus 100. Right, that's my 4ac all over 2a, which is 2. All right, so let's do a little tidying up then. We got minus 6 plus or minus, so I've got square root of minus 64 now, minus 64 over 2. All right, minus 6 plus or minus, I've got this minus 64, square root of minus 64, so we've got that as plus or minus 8i all over 2, and we can tidy it up again, can't we? Just make it minus 3 plus or minus 4. Okay, so we've got our two solutions there. We've got minus 3 plus 4i, minus 3 minus 4i. And again, you see you've got that pair of solutions that go with each other. Okay, so if you wanted, you could have done it by, completing the square, making it z plus 3 squared, and then you've got to take away the 9 and the 25 equals 0. So we got 6, 4, have I done it right? 16, 4. Yeah, that's right. So you've got z plus 3 all squared plus 16 equals 0. And then what are you going to do? Subtract 16, haven't you? So z plus 3. Oops, don't want to do that. So z plus 3 all squared equals minus 16, square root it, z plus 3 equals plus or minus 4i, and z equals minus 3 plus or minus 4i. So obviously we're going to end up with the same solution, but just putting it out there as an alternative. You might prefer one to the other. Okay. Again, you got that pair of solutions. All right. So again, we're not going to have time to do all of these. So pick one out, have a go. See if you can get the solutions for me. And again, pop it in the chat, just as long as you label it 1A, 2C, whichever one you're doing. And we'll see if we can get a couple of these in a minute. Probably 5 or 6 minutes. Here we go. Preferences. Looking good. 15. Yep. All right, good. Any other solutions? Over 4. Let me just write something for that one there. Not quite on 1F. 4z squared is -1. Z squared -1/4. We've got to square root it, right? We should be looking for plus or minus I over 2 for F there. -5 plus or minus I. Fantastic, excellent. Yeah, 3D -5 plus or minus I. Yeah. Okay. All right. So we've got a good few answers there. And just do a bit of practice and should be fine with those. Just notice at the top there, so do not use your calculator in this exercise. It's getting used to you doing that thing, but literally the new calculator we talk about, the sort of the whiteboard one that we've mentioned, will solve quadratic equations for you. It will tell you what the solutions are. It will tell you what the minimum point of the quadratic is as well. Even if the answers are complex. So you can literally, for example, 3D here, you can type, well, it'll be x, but you can type x squared plus 10x plus 26 equals 0 into your calculator. But you only need to fill in the coefficients. It's got a quadratic thing. And you just press equals and it will give you the solutions. Very handy and well worth doing, but I think the process of understanding what we're doing is sort of valuable as well here. Okay, so okay. Just be a little bit clearer now. I can see myself and see what I'm showing you. Just to finish off really and say, obviously again, another brief introduction to further maths. Obviously you'd get more time spent on doing those questions, practicing those questions, and we'd probably move on much quicker, which is, you'd be moving on to the next bit, a little bit more difficult, Those two sets of questions that are on there, they literally are the first couple of exercises in this book, which is the one that you should be looking out for to get further maths. And as I said, so again, when you start in September, we'll start looking at complex numbers, and probably lesson 1, do those little bits as a catch up, because you've done them a little bit today, you probably remember, and your summer task incorporates quite a bit of it as well. So we'll probably move through things quite quickly. You'll find us going quite quick. So that's the book you're looking out for further maths, and I've not got all the other ones with me, but you can see them on the back. I'll try and show them all there. So this one is the one I've just shown you. We'd be needing this red one here, and this orange one here, and none of the others down there. Okay, so it's just that one, the red one, and the orange one, and then into the year 2, you have the year 2 green one there. Okay. And they're the other ones for the normal maths, which obviously we spoke about in the other session. And I would say, you know, if you're doing further maths, get that whole set there, all 4 of them, because you're definitely going to need the ones in year 2 anyway. I'd say get them early on; they'll help you out in year 1 as you're doing further maths. You're going to go much quicker than the other groups that are only sticking with these. The first 2 to start off with. So, it's quite a bit of an expense, but it's well worth having your own copies. Really, you can do what you want with them. So those 4 and these 3, I would suggest you get all 7 of those to begin with. Really, this one you could wait a little bit longer, but if you're buying 7, you may buy 8, right? Or maybe if you're thinking you might not continue into the following year, not do that. Okay, and so we've done the sort of main part of the teaching, but we were just looking at complex numbers. This is recorded, so you can have a little catch up on that. If you've got any questions or anything, or want me to just have a little chat for a few minutes afterwards, more than happy to do that and help you out with stuff. But say very similar to the other one, you'll have a summer task. So you're doing maths and further maths. You'll have 2 maths summer tasks effectively. You do the sort of more, the more basic algebra one for key skills one for normal maths, and then the one which is based around complex numbers for further maths. And that's it. It's about being organised, working hard, and doing lots of good stuff. So. So if you've got any questions, please feel free to hang around and ask them. Otherwise, I'm finished for today, and I look forward to seeing you all in September and doing some more further maths with you. Bye, everyone.